So every time I had some sessions, I end up doing something interesting. I remember last time I had this session at RSA, and the topic was using the science of habits in cybersecurity. So just before the event, before the session, I was taking some notes on a piece of paper and had a coffee in another hand. I met somebody on the way, and then my time came up. Just before that, I wanted to dispose the coffee, so went to a bin, went up on stage, and then I noticed that I disposed my notes and came up on stage with the coffee. So this time it was slightly more interesting, maybe. Until a few hours back, I thought my session is tomorrow. So thanks to Jay, he mentioned, no, it's today. So thanks all of you. Great to see all of you. So I know right now there's AI all across, right? We are seeing AI in every aspect of life. So what I'm going to do is I'm going to talk about some of the things, some of the applications of AI in the field of offensive security. And I'll also show a few things, a few demonstrations of what it can do today and probably what it can be tomorrow. So there are some fundamental shifts which are happening in AI across the board. But when it comes to offensive security, I think the time has just started. When you look at copywriting, editing, creating videos and text, things are very mature. But when it comes to offensive security, I think it has just got started. And what we are about to see is probably going to be very, very interesting. This is one thing which I wanted to talk about. Like, if you think of hacking the way it used to be, like we have this lone hacker sitting in their room writing 0 days and exploits. But today, I think with the AI, things are going to be different. So the power of lone hacker, it's going to be there, but today in the field of AI, it's not just about the mindset of breaking things. You need a few more capabilities together. You need the mindset of breaking things, but along with that, you need the mindset of building things, which are two very opposite nature. In my team, the hackers and the builders are generally different folks, most of the times. And you also need the mindset of maths, you need the compute power. So I believe that there's going to be a shift from the lone individual great hackers to more of institutions like academia and the industry. So you will probably see more of innovations coming from the industry than what we used to see before, like Dan Kaminsky coming and breaking the internet. Of course, those things are going to happen, but it's going to become more and more difficult. So you will see more innovations coming from institutions. So another aspect of hacking is going to be that moving from deterministic hacking to something more non-deterministic. And probably hacking is going to change. I mean, that's for sure is going to happen. But it might become more difficult. I know this might be slightly contrary to what normally we think, but I'll take you through an example. Very early days of spams, like anti-spam filters when it came up, like 20 years back. Those days we used to have all these classifiers to distinguish between spam and non-spam. And any of you remember something called the Occam's razor, where we had this list of all these? Anybody remember? Huh? OK. So there used to be all these rules which are written in order to catch these bad emails or these spams. So that was the first generation of anti-spam. Then came the statistical algorithms. I mean, some very simple ones like naive Bayesian and stuff like that. And as more and more machine learning came up, today you can see it is much more difficult to send a spam. Or like marketeers find it very difficult to even land their emails, right? So it has become very non-deterministic. I believe that the future of hacking is also going to be like this. same thing. What happened to spam is also going to happen to hacking. The deterministic way of hacking is going to be very hard because in every layer of defense, you will have all these statistical and non-deterministic models of either preventing things or catching things. So that deterministic path to break is going to be a lot more harder. So if we play it well, I think for the first time in the history, defenders may have a better hand. Now, time will tell whether this is true or not, but this is for the first time that there will be a shift compared to before, where the bad guys had a better hand. At the same time, as I have that optimistic view, at the same time, there's also going to be a pessimistic side, which is just like we saw that great digital divide, I believe there's going to be a great AI divide. There's going to be a shift in speed, scope, sophistication. And if you look at pen testing today, how we do pen testing today, mostly once a year on 20% of the assets. And that's not going to be enough because bad guys are moving much, much faster. And also, this sophistication is also going to change. Like, for example, if you think of pen testing of today, how do we do? Pen testing means scoped assets. Like, here's an application, you got to break into that application. But fast forward, or even today, the way hackers are breaking into is not necessarily just breaking into your main application. I'll give you an example. Imagine you have a production system, and the production system is quite safe. But you got a pre-prod, and there's somebody who makes some new change in the pre-prod. The pre-prod, for some reason, is accessible to the attacker, and the pre-prod has got a directory traversal. In that directory, you see some logs. In the logs, you see the admin password, and you see that the prod and pre-prod has got the same admin password. Now, suddenly, the prod gets broken because of the pre-prod. Now, generally, when we do pen testing, we don't give these kind of examples as scope. As hacking is going to become, in a way, more scalable because of AI, we will see more of this kind of multi-stage attacks. So those who do not adapt to this new model, to this new world, there will be a great AI divide for them. So at the same time, when I have a very optimistic view that for the first time in the history of the world, the defenders may have an advantage over the attackers. At the same time, if we don't adopt, there will be a great divide as well. So here's something which I just wanted to talk about. I know a lot of, everybody has seen this research, like 90% of AI projects fail. How many of you have seen this research? None of you? Okay, some of you have seen, right? Okay, so this became like an internet sensation some time back. Now, there's one interesting thing which is also true is 90% of startups fail. 90% of anything new that we do fails. But mostly the reason why startups fail or anything new fails is not because of startup or that's something new, or in this case it's the AI. It is because of we like this shiny new hammer and everything looks like a nail. A lot of times we don't choose the right problem. So I see most of the times in case of startups, in case of most of the projects, people end up picking the wrong problem. That's one of the biggest reasons why AI projects are failing. Having unrealistic expectations, not knowing what to expect, and not having the right kind of setup to make the program successful, not having the right team. But it's not really about AI. So I have a very optimistic view of the future, and future is something which we will create it. So if we have an optimistic view, I think we have a better chance. I want to move from here to the second part, which is on the AI taxonomy. I know that a lot of us think about AI in a particular manner, which is like thinking of ChatGPT, thinking of learning. If we don't say learning, we think it's not AI. But AI is much broader than what we typically perceive AI as. So I wanted to give a broad glimpse of that. So if you look at the broad taxonomy of AI, so we all know about these generative models, which is like a very small subset of the overall artificial intelligence. The biggest circle, which is the broader circle, you will see things like search. Like, we don't think of search as AI, but any of you who have studied AI in your school, I guess search is the first chapter of any AI book. So search is AI. We have reasoning, we have planning algorithms, which are part of AI. Then we have machine learning. I know machine learning had been a hot topic for quite some time. Then came the neural networks and the generative models. So when we look at AI, I believe it's very important that we look at AI with this broader perspective, not look at AI as ChatGPT or some learning models. Then we are going to miss the bus. And if you think of even neural nets, things got started in 1950s. It's something very, very old. It's not something new. It's just that things started happening too fast in last 5 years. So looking at AI from that broader perspective is going to help us be more successful in our AI implementations. So let's look at the search algorithms. So I'm not going to get into the full details of like A-star algorithms and the adversarial search algorithms, but at a broad conceptual level, like we talked about search, like search could be AI, right? So there could be a scenario where you know the map. You know that you have to go from here to a specific hotel in Paris. You got to find out the best possible path. So that's one kind, where the terrain is broadly fixed. The map is not changing. But then there could be also a kind of search where you have an adversary, where things are changing. Things are no longer static, like a map. So there you need adversarial search algorithms. And these search algorithms are actually very interesting in the context of offensive security, in the context of pen testing, because you, in a way, have to find your way. You have to find the path to your goal, right? So this kind of search algorithms becomes very interesting. Like, for example, I spoke about A-star algorithm. A-star algorithm is where things are not changing. It's not dynamic. So there are many variations of A-star algorithm, like memory-bound A-star, MA-star algorithm. You have the adversarial search algorithms. In case of like min-max algorithms. So adversarial search becomes very pertinent because now you have to hack, and while you are hacking, you also have the blue team on the other side. They're trying to catch you, right? So this kind of, or this class of algorithms also becomes very interesting. Then another class of AI which becomes very interesting is the planning AI. And when you look at any of the textbooks in AI, you will see dedicated chapters on planning. Now, I'm sure all of you know about attack trees, right? Attack trees which help you to, like the path which takes you to your goal. Incidentally, like Bruce Schneier, I'm sure most of you know of Bruce. So Bruce Schneier is one of the creators of the concept of attack trees. And Bruce, incidentally, is also one of our advisors at FireCompass. So the concept of attack trees came up like 20 years back. It's not something new. It's like 20 years old. But the challenge is to find out all these possible attack paths. Now, I'll talk about the complexity of that. But before that, let's think about this as a concept. Like, how do we plan? So if you have to think of, like, imagine cooking. If you have to make omelet, you know that these are the steps. But there could be, in those steps, something is missing. Or maybe somebody has got some dietary constraint. So based on certain constraints, now you may have to think of the plan in a different manner. You might want to cook a specific dish. You open the refrigerator door, and you see those things are not there. Now you got to plan things, right? How do you still achieve your goal with certain constraints? Now, planning may not be very deterministic in nature. It may not be very straightforward. So it is evolving. Things has to change. So how do we look at planning in case of these planning algorithms in AI? So think of every action having some preconditions and post-conditions. So if something is true, then the action takes place. And if that action takes place, then there's a post-condition. So what you have now is a lot of set of actions with preconditions and post-conditions. But you don't have a plan. So you know that salt and pepper goes together. I mean, that's something which you know. Or you know there could be some non-obvious pairings, which might be like chocolate and chili. I don't know if you knew this, but this is an interesting pairing that works, which is non-obvious. So a great chef, a great Michelin star chef, will be able to create different recipes based on this kind of small things in their mind. They know this goes with this doesn't go with this, and they can create a whole new recipe out of it. So in case of planning, think of being that chef which can create now these attack plans. You know that if this port is open, then you could try this exploit. That's a simpler way of thinking. So I can now model the network and the vulnerabilities into all these kind of various states. Each of the systems has a specific state, and we know if this state is true, then we can take this action. And if that action is successful, then this is the post condition. So we can build this kind of plans in different ways. Like there's something called the forward chaining. What you do is you open the refrigerator, you see that here are the ingredients which are out there, and based on that, you think of the recipe. And you build the recipe based on what you have. So you kind of do a forward chaining. You know that here's an open port, I could do this, I got this initial access, can I do privilege escalation, can I do lateral movement? So we build forward the plan. That's one way of doing it. Then there is backward chaining. In case of backward chaining, the way you look into it is you have a red team objective. The red team objective could be get PII information. Now you look at like where is that PII information, and then you work backwards and you do a backward chaining. Now the challenge for solving this is the moment you look at a network which has got like, say, a few hundred nodes, just a few hundred nodes, the number of possibilities of states are so huge, and the number of possible types of actions are so huge that it becomes computationally almost infeasible if you have to find all possible paths. So that's where all these smart algorithms comes in. That's where we need to figure out how can we do this attack planning better. So if we have to solve pen testing, red teaming, we got to solve planning problem better. So I'll show you a quick demo of this. Now, I actually started so this is our AI agent at FireCompass. I gave it a prompt like try a APT-style pen test on this specific asset. So it did certain execution. OK, so I just started this a while back. What I'm going to do is I have a recorded demo. If I start it now, it's going to take like 30 to 40 minutes. So I'm going to take you through a quick recorded demo, which is highly edited. So here you can see that the agent is first thinking what all things it should do. Now, of course, you can go to ChatGPT and ask, like, what all things can we do? ChatGPT is going to give you a certain recommendation, but it's not going to be able to execute. So here you are seeing that it's actually going to execute that based on the findings, is going to make the decision in terms of what's the next step could be. So it just did the SMB client enumeration. I'll skip this a little bit and I'll show you the visual representation of this. The best is, let me take you through the visual representation instead of running through the full demo. So this is what it did. Like, this is the post the execution. You can see it did the nmap scan. So then it did the SMB share enumeration. It got the first credential. And you can also see the nodes where, in the planning nodes, where it failed. It anticipated that I could try this, but it tried and it failed. The green ones are successful. So it also did the SMB spray. It found out more valid users. It did the LDAP enumeration, got the creds. And here it got the initial access. So now, of course, like when we think of doing pen testing ourselves, this is how we are doing pen testing ourselves, right? But now agents can also think in that manner, and it can make those decisions on its own and plan things forward. So this is an example of planning. So when we look at a network and try to find out all possible paths, it becomes very complex. It becomes very hard to kind of enumerate all the possible paths. In case of application, it has got a different kind of complexity. So the question is, how much can these agents do in the long run? Can it be as good as humans? Can it be better? So time will tell, but the early results are extremely promising. There's a very good chance that the agents are going to become better than 95 or maybe even 99% of the humans. So I kind of believe that. I have seen some of the work which many other researchers are doing. So there's a very high chance that the agents are going to become better than 99% of the humans. So if that happens, then the whole world of pen testing is going to look different. If it doesn't happen, of course, it'll be slightly different. But at the end of the day, definitely it's going to become better than 80% of the humans. So then, what next? Like, how do we then work together with AI? I know that there had been a few sessions on that. This is going to be very, very important even for pen testers. I don't believe that the future is going to be that of robocops. It's not going to be 100% automated. It's going to be a combination of man and woman, or humans and machines. So my view is it's going to be more like Iron Man than like robocops, but it's going to be way, way better than what we can today imagine. Let's look into another class of problem which is highly overlooked as AI. But it is there in most of the AI systems in many different forms, which is classification. So if you are planning to use AI in different fields, there's a high chance that you will see classification will be very, very pertinent. And within classification, a very simple algorithm, very old algorithm, which kind of takes the center stage, which becomes very, very useful in a lot of occasions, is the naive Bayesian algorithm. I'll very quickly talk about this as a concept. And spams, or the anti-spam filters, those are great examples. So think of, if there's a specific word free in an email, what's the chance that the email is a spam? There's some possibility, right? Like a lot of spammers use the word free, or there could be highly spammy words, and you know that if this word is there in an email, there's the probability of X percentage that the email is spam. Similarly, you can see like these are the words which are typically there in good emails. Those are generally not there in the spams, so the probability is very low. So you can find out such kind of probabilities of each of these tokens appearing in good versus bad emails. So once you have this data point based on your training set, you can use very simple naive Bayesian classifier to figure out that if these all tokens are there in the email, like now you have in the email, suppose 30 different characters or tokens. The tokens are generally not the words, tokens are done differently. But suppose you have like these 100 different tokens. So given that there are these 100 different tokens, what's the probability that the email is spam? So it's a very simple algorithm, but highly, highly useful in a lot of different contexts. Not just in anti-spam, but in many other contexts. So I know all of you know about retrieval augmented generation, RAGs. I'll not talk about it. RAG is like overused term across the board. So we'll move in the next part in terms of what are some of the examples of AI that we can use in offensive security. Any of you are working on AI and using it for pen testing, red teaming, any of the use cases? Like where you are working on research, on AI research? Any of you? Okay, so I'm sure most of you are using AI, right? So we spoke about the classifiers. Now, the classifiers could be used for figuring out a lot of different challenges. Like in one of the contexts where we use classifiers at FireCompass is that at FireCompass, we have a platform for red teaming. So it does the reconnaissance, it does the attack planning, then it actually goes and runs these attacks, does the lateral movement and stuff like that. So one of the interesting thing is, like if you are a red teamer, you get a hunch, right? Like this is an interesting target I should go after. And then you go after that target. You don't go after all the targets. If it's a large organization, there might be thousands of targets. You don't go after all the targets. You go after a few set of targets where you have a gut feeling. Like how can we have a similar gut feeling using AI, where it can identify that these are the potential targets we should go after. So you can use classification over there. So that's one of the use cases of classifiers. You are suppose trying to figure out that here's a network, this is the map, I have to reach this particular destination. How do I pivot? How do I move from one host to another? How do I do lateral movement? So that's another place where you can use many of these reasoning and planning algorithms. I'm not taking you through each of these, but if any of you are interested in this, you can look at Monte Carlo tree search or GNNs and multiple other algorithms which are out there. Then comes the LLMs. So this is something I'm sure all of you are using, right? Like you can use LLMs to now generate exploits, you can write code. Things have become much more easy compared to before. So that's definitely one very important part. But the retrieval augmented generation, this is something where this is what kind of differentiates between successful and unsuccessful projects. Not just in case of pen testing, but also in case of coding. If you can use RAG and give that right set of data to the LLMs so that it can give you more fine-tuned results for you, that's where great success comes. So I would definitely suggest exploring RAG in a much more deeper manner, not just the simplistic manner in which it is out there in ChatGPT. That's going to be very, very powerful. And I'll show you a few other interesting stuff out there. And last but not the least is the agentic AI. Now, I'm sure all of you have explored agentic AI. The key difference between the LLMs and the agentic AI is that LLMs can only tell or predict the next token. Rock, paper, and we know that the next thing is scissors, right? Like it just spits out what's that next thing could be. So it's great at that. And it's astounding that just with that as a goal, it can generate such kind of wonderful poetry, literature, images, and code and stuff like that. I had been passionate about AI for last 25 years or so. I could never imagine that this could be possible, like what it does today. So it's really, really interesting. But then it can only suggest certain things, right? Like it cannot do things for you. So the agentic AI is going to be the key thing in pen testing, because at the end of the day, you want AI to take actions. It should not just tell you, hey, you can do the port scan, or you can try this exploit. It should be able to run that exploit. It should be able to create custom payloads based on the context. So the agentic AI, which can achieve end-to-end goal, that's the future. And at FireCompass, that's the key area where we focus on. And I believe for the entire industry, the LLMs are going to be more like operating system, is the agentic AI, which are the applications. So any of you who are interested in AI, I would definitely say this is the place to look into. Everything in the future will be, like with a pinch of salt, agents. So there will be, I don't know, billions and billions of agents out there, and there are a lot of interesting projects which are happening. Like in MIT right now, there's a project called Project Nanda, creating a DNS equivalent for agents. So the way we look at the world tomorrow is going to be very different. We will have a lot of our personal agents in our pocket roaming around, and there will be all these billions of agents across. So just like there had been this internet revolution, we are going to go through this agentic revolution. Now, having said that, the AI journey will also need some amount of fine-tuning. You can't always take things and just use it. And I'll give you an example. Like in the context of security, if you look at the way ChatGPT or OpenAI has learned things, it has certain limitations. So there are lexical sparsities, like the language which we speak in the world of hackers versus the data with which ChatGPT got trained may not exactly match. There's also semantic drift. So I'll give you some example of, like we took OpenAI and we looked at, so this is called principal component analysis. Each of these words or tokens are generally vectorized. And if you take all these vectors and try to figure out like how similar are they, you can try to achieve that through principal component analysis and figure out from that distance how far apart they are. So that's like in very simple terms. Now, if you look at this, this is from OpenAI-based data. If we look at SQL injection and SQL hunting, you can see that they are quite far apart. Even though we all know that these two are very similar, based on the OpenAI data, when we looked into it, these are far apart. So it's not able to understand that these are very similar in nature. So we needed to do fine-tuning. And after we did certain tuning, we could now bring them closer. So you can't always take LLMs as is and put it into your context. You might have to do certain work on that. So fine-tuning of AI is going to be super, super important. If we just directly use it as is, you may not have that kind of results which you want to have. So here's a quick summarization of what I believe the future of offensive security testing is going to be like, and then we'll close it here. So one thing which I'm kind of very sure is the vulnerability assessment is dead. I mean, it really doesn't make sense to get so many alerts, so many false positives. It's going to change in a drastic manner. I believe that pen testing is probably the way to go. You have to do prioritization of some form. I mean, either through pen testing or through some correlation, you have to do that. So VA in its original form is not going to work anymore. We have to move away from this 20% pen testing of assets to pen testing all our assets. I spoke about this example of how attackers are moving from a pre-prod, doing lateral movement from a pre-prod to a prod, and people generally don't pen test their pre-prods, or sometimes they don't pen test their prods also. So having complete coverage in case of pen testing, this is definitely a must. The point-in-time pen testing is definitely not going to work. So like 5 years back when we thought about this concept of continuous automated red teaming, how many of you know about CART, C-A-R-T, or use this as a terminology? Some of you, right? So when we thought about continuous automated red teaming or CART, it was a little bit ahead of time. But I think today with the AI revolution, we don't have any option. The reason is you can't just look at siloed assets, you have to look at lateral movements. You can't do red teaming just based on a few goals. You have to have all the different red team objectives automated. So moving from point in time to continuous, either pen testing, red teaming is going to be very, very important. And last but not the least, it has to be AI plus humans together. But how is that going to work together? We have to figure that out. Because initially, I believe in a year or so, we might see AI surpassing 95% of the humans. So that might become very intimidating. And I'm pretty confident it's going to happen. So there will be a kind of scrambling, like how do we then integrate? How do we work together? So there will be new things which will come up, but this is the point in time I believe that all of you should look into how do we combine, join hands with AI in a much more effective manner. So with this, I'd like to end the slides. Thank you so much.